Historic robot collaboration. AI systems team up on ISS. ICHIBAN mission breakthrough. Imagine a future where robots from different countries work side by side in space. Sounds like science fiction, right? But it's now a reality, and it's setting the stage for even bigger leaps in human-robot teamwork beyond our planet. That's precisely what happened with Mission ICHIBAN, a groundbreaking collaboration between the German Aerospace Center, DLR, and the Japan Aerospace Exploration Agency, JAXA. For the first time ever, two astronaut assist robots, each developed through their respective national programs, successfully communicated and worked together on board the International Space Station, ISS. This mission, named ICHIBAN, which means first in Japanese, wrapped up on July 29th. Its primary aim? To determine whether multiple robots, built with differing technologies and languages, could not only operate simultaneously on the ISS, but also truly cooperate in real time. Two advanced robotic helpers took center stage. CIMON, created by DLR in partnership with Airbus and IBM, and INTBAL-2, a product of JAXA's ingenuity. CIMON, first introduced in 2018, looks like a floating sphere about the size of a volleyball, a marvel of 3D printing and AI technology powered by IBM's watsonx platform. Normally, the Swiss ESA Operations Center Biotask guides its movements and tasks within the European Columbus module. On the other hand, INTBAL-2, which has been operating in the Japanese Kibo module since 2023, builds on JAXA's earlier camera drone designs. Its job is to capture video of astronauts at work, all remotely controlled by mission managers back in Tsukuba, Japan. By doing so, it streamlines the documentation process and frees up the astronauts for more critical tasks. However, before ICHIBAN, INTBAL-2 was never intended to interact with other robots. This was the game-changing experiment. Here's where things get intriguing. Takuya Onishi, a JAXA astronaut aboard the ISS, initiated the robot teamwork by issuing voice commands to CIMON, using it as a sophisticated language interface. IBM's AI processed these commands, understood what was needed, and transformed them into actionable instructions for INTBAL-2. Suddenly, INTBAL-2 wasn't just a cameraman. It became a teammate able to act upon tasks defined by another robot. So, what did this robot duo accomplish? INTBAL-2 received a command to search for several items hidden around the Kibo module, including a Rubik's Cube, a hammer, a set of screwdrivers, and a decommissioned INTBAL. After tracking them down, it sent live video feeds and location information to CIMON, enabling Takuya Onishi to verify the object's positions remotely. This demonstrated a whole new level of robotic synergy. Here's the part most people miss. Until now, any footage INTBAL-2 gathered could only be beamed down to the ground control center in Tsukuba. The breakthrough here was INTBAL-2's ability to relay images in real time directly to another robot on the ISS. This paves the way for a network of intelligent robots working in concert, not just with humans, but with each other, right there in space. Let's break down the workflow for clarity. 1. The astronaut sends a voice command to CIMON, telling INTBAL-2 what to do. 2. CIMON transmits that voice order to an AI server on Earth, which figures out the task's purpose. 3. The processed command travels back to the ISS over the station's internal network. 4. CIMON receives this and relays the instruction to INTBAL-2, which then carries out the task, like hunting down objects, and then shares visual feedback with CIMON for astronaut verification. This innovative step, turning robotic assistants into genuine collaborators, raises big questions. Will we see fully autonomous robot crews handling emergencies or complex repairs on future Moon or Mars missions? Should robots ultimately have more autonomy in orbital environments, or does this risk missing valuable human insight? Some people argue that increased robotic autonomy could one day minimize human presence, while others say true synergy will only happen when people and machines work as partners. What do you think? Will this kind of robot cooperation redefine the future of space exploration, Or is there a limit to how far humans should trust machines on their own? Share your thoughts below. Do you see this as a huge leap forward? Or are there risks and trade-offs we can't ignore? Groundbreaking collaboration. Germany and Japan's ISS robots team up. Imagine a world where robots from different countries, designed entirely independently, can team up to accomplish tasks in space. Sounds like science fiction, right? But last week, this futuristic vision became a reality aboard the International Space Station, ISS. Japan's space agency, JAXA, and Germany's DLR successfully orchestrated what they're calling the first-ever collaboration between two robots developed separately, each with its own unique capabilities. And this is the part most people miss. These robots weren't originally designed to work together, yet they pulled off an impressive joint mission that could shape the future of space exploration. The stars of this groundbreaking experiment were Japan's INT-BAL-2, a drone capable of flying autonomously inside the ISS, and Germany's CIMON, a voice-activated AI companion designed to assist astronauts. The mission involved a seek and photograph task where CIMON acted as the brains of the operation, interpreting commands from Japanese astronaut Takuya Onishi, while INT-BAL-2 served as the eyes and hands, flying around to locate and document items within the station. INT-BAL-2, officially known as the GEM Inboard Portable Video Camera System Demonstration Unit 2, is essentially a floating camera drone. It's controlled remotely by JAXA staff on the ground and can capture images or videos without requiring an astronaut's direct involvement. This ability is crucial because it frees up valuable time for astronauts, who often have packed schedules filled with scientific experiments and maintenance tasks. Meanwhile, CIMON, short for Crew Interactive Mobile Companion, is equipped with advanced AI and voice recognition technology, courtesy of contributions from Airbus and IBM. Astronauts can give verbal instructions to CIMON, which then processes those commands and retrieves relevant information, or performs requested actions. But here's where it gets controversial. Despite being developed separately, with no initial plans for collaboration, these two robots managed to communicate seamlessly during the experiment. Last week, astronaut Takuya Onishi put their teamwork to the test in the Columbus European Laboratory module. He instructed CIMON to relay a command to INT-BAL-2, asking it to locate an object in the Kibo Japanese experiment module. CIMON understood the request, translated it into a format that INT-BAL-2 could process, and transmitted the instructions to the Japanese drone. INT-BAL-2 executed the task flawlessly, streaming live video footage back to CIMON, which displayed it on its screen so Onishi could monitor the operation in real time. This achievement marks a significant milestone in space robotics. According to JAXA, this is the first instance of two independently developed robots collaborating in orbit, a feat that required overcoming challenges related to communication protocols, operational compatibility, and cross-cultural coordination. The success of this experiment has far-reaching implications for future manned space missions. As JAXA noted, the insights gained from this mission could lay the groundwork for more efficient partnerships between humans and robots in space. For example, imagine a scenario where robots handle routine inspections or repairs, while astronauts focus on complex scientific research. Or consider how such collaborations might enhance safety during long-duration missions to the Moon or Mars. These possibilities are exciting, but they also raise questions worth debating. Should we prioritize developing universal standards for robotic interoperability in space? Could over-reliance on automation lead to unforeseen risks? And how do we ensure equitable contributions from international partners in collaborative projects? As humanity continues to push the boundaries of space exploration, experiments like this one remind us of the power of innovation and cooperation. What are your thoughts on this historic collaboration? Do you think it's a step forward for space exploration, or do concerns about over-automation outweigh the benefits? Share your opinions in the comments below. We'd love to hear what you think.